welcome to the Cabinet of Science and Fiction.
Hello.
Today we're diving deep into a collection of writings exploring, well, the fascinating and sometimes pretty surprising intersection of fact and fiction in the history of scientific discovery.
Yeah, it's really interesting stuff. And for you, the learner, someone looking to get a grip on complex ideas quickly, find those aha moments without, feeling totally overwhelmed.
Exactly.
We've been looking at John Waller's fabulous science, fact and fiction in the history of scientific discovery. It's a book that really makes you rethink the standard stories we hear about science.
It really does. It looks critically at the lives, the discoveries of some really big names in science.
Right.
So our mission today is to unpack some of Waller's main arguments and, honestly, some of the really intriguing stories he brings up. We want to show how the histories we often just accept might be quite different from the messy reality of how science actually moves forward.
Messy is a good word for it sometimes.
We'll look at cases where myth has sort of taken over from reality, where context turns out to be absolutely crucial, and where things like human ambition, even errors, played surprisingly big roles.
Okay,
so let's jump right in. Waller opens his book by contrasting Macaulay's famous romantic poem about Horatius at the bridge with the actual historical reality, which was Rome's defeat.
Yeah, that's a powerful opening.
It really sets the stage, illustrating this broader human habit, maybe, of creating these stirring, often embellished stories.
Yeah.
So how does that connect to how we understand scientific breakthroughs and the scientists behind them?
Well, it connects directly, I think. Just like those epic poems were meant to inspire or maybe build national pride, we often get these very polished, almost mythical accounts of scientific discoveries.
The lone genius narrative.
Exactly. The lone genius, the sudden eureka moment, the triumphant overcoming of all obstacles. Waller's comparisons suggest our view of science history is just as prone to this desire for a good, clean story. We want heroes. We want clear progress.
Right. We like neat narratives.
Yeah.
And Waller then challenges this head on, arguing that many of our scientific saints, as it were, weren't quite as flawless as the myths suggest. He mentions Pasteur, Lister, Fleming, names everyone knows. So based on the excerpts, maybe we could dig into Louis Pasteur first, specifically his work on spontaneous generation.
Sure.
Waller highlights how Pasteur, even though he was ultimately on the winning side of that debate, didn't always stick to the absolute strictest scientific standards. And his arguments weren't initially seen as completely incontrovertible. He talks about Pasteur's dealings with Pouchet and Bastian.
Yeah, that's a key example. What's really important to grasp is that the whole spontaneous generation debate wasn't like black and white from the start.
Go ahead.
Pouchet and Bastian, they had their own experiments, their own evidence that they genuinely believed supported their side. Waller points out that Pasteur, while an incredibly skilled experimenter, no doubt, his approach wasn't always what we'd now call perfectly rigorous. For instance, his argument about Pouchet's experiments being flawed by mercury contamination. That might have been true, but Waller suggests Pasteur presented it with a level of certainty that maybe, just maybe, went beyond the hard evidence available at that specific time.
Interesting. So it wasn't just about the data.
Not entirely. The takeaway isn't that Pasteur was wrong in the end, but that even this apparently clear-cut scientific victory was complex. There were strong arguments on both sides and maybe a bit of persuasive rhetoric, pushing things along.
It reminds you that science isn't always just a straight line of perfect experiments.
Definitely not.
Waller mentions Pasteur's experiment sterilizing blood and urine without heat, and microorganisms only showing up when exposed to air. I mean, that sounds pretty convincing on the surface.
It does. It really does sound convincing now. But Pouchet and his supporters had counter-arguments ready. Well, they suggested that maybe Pasteur's heating methods actually destroyed some vital vegetative force needed for life to just arise. Then Pasteur gave this incredibly persuasive lecture at the Sorbonne.
Ah, the famous one.
Yeah. Waller describes it as a real turning point. Pasteur seemed to prove Pouchet's mercury was contaminated. But, and this is crucial, Waller emphasizes that even Pasteur's own private notebooks suggest he was driven more by his strong conviction, his belief he was right, than by absolutely irrefutable proof at that moment. And the fact that Pasteur seemed to kind of sidestep directly addressing Pouchet's experiments done high up in the Pyrenees Mountains, where the air was presumably purer.
Right, different conditions.
That hints at this less than perfect picture of absolute scientific certainty.
And then it gets even more complex with H. Charlton Bastian, right? Waller describes Pasteur almost refusing to engage directly when Bastian claimed he had evidence of spontaneous generation happening in neutral or alkaline urine.
Exactly. Bastian had specific experimental conditions he wanted to focus on, which is perfectly reasonable science. You define your terms.
Sure.
But the Pasteur camp, as Waller puts it, seemed reluctant. They wanted to control the terms of the debate. And what Waller reveals is that privately, Pasteur and his team did take Bastian seriously.
So behind the scenes.
Behind the scenes, they ran their own secret tests on Bastian's claims, which suggests, a level of underlying uncertainty that doesn't quite fit the heroic image of the totally confident scientist who knows he's right.
So Waller's picture of Pasteur is more human. Driven, brilliant, ultimately correct, but not operating with flawless objectivity all the time.
That's a good way to put it. Very human, very driven.
Okay, let's shift gears. Waller then looks at Robert Millikan and his hugely famous oil drop experiment, measuring the charge of the electron.
A cornerstone of physics.
Absolutely. But the book brings up some pretty serious accusations of, well, data manipulation. It even quotes Millikan's own notebooks and mentions the contrasting findings of another physicist, Felix Ehrenhaft. This really hits at the idea of pure objectivity in science, doesn't it?
It really does. It's quite startling, actually, to see Millikan's private notes next to his published work.
What did they say?
Things like, "This is almost exactly right and the best one I ever had," or "Publish this beautiful one," and then right alongside, notes about discarding results that were too high or just won't work.
Wow.
It shows a significant amount of personal judgment filtering the data. Waller points out this major discrepancy. Millikan claimed in his paper he included all of those studied for 60 consecutive days, no single drop being omitted.
But that wasn't true.
The notebooks suggest otherwise. A significant chunk of his experimental data apparently never made it into the published paper. So he wasn't just passively recording, he was actively selecting, choosing what fit.
So selecting results that confirmed what he already thought. Confirmation bias.
Precisely. Waller highlights how Millikan even used the word beauty in his notes, but it seemed kind of circular. A result was beautiful if it was close to the value he expected based on existing theory.
And Ehrenhaft, what about his results?
Well, Felix Ehrenhaft, who actually also initially believed in atomic theory, did his own experiments. And his data, interestingly, could be interpreted to support a continuous range of electrical charges, not just the discrete electron charge Millikan found. That was a competing idea at the time.
So the evidence was ambiguous.
Waller argues it was ambiguous enough back then that being right in the long run wasn't necessarily the same as being the better or more objective scientist at that moment. Ehrenhaft kept working on his ideas for decades, even though they weren't widely accepted. It really underlines the ambiguity.
It reaches that fundamental question about objectivity. And Waller connects this to Arthur Eddington too, right?
Yes, Eddington and the famous Eclipse expeditions in 1919, the ones that supposedly gave definitive proof for Einstein's theory of general relativity.
Another foundational moment in science.
Huge. But Waller suggests Eddington, who was already a known, very strong supporter of Einstein.
Okay, so he wasn't neutral going in.
Not really. Waller argues he may have selectively interpreted and presented the data from those expeditions.
What were the challenges with those eclipse observations? I imagine they weren't easy.
Incredibly difficult. You're trying to measure the tiny bending of starlight as it passes the sun's gravity. You can only do it during a very brief total solar eclipse.
Right.
And you're often doing it in challenging conditions, heat, atmospheric turbulence, things that can easily mess up these super precise measurements.
And the stars themselves?
Waller points out the stars closest to the sun, where the bending effect should be strongest, were often hidden by the sun's corona. So you're left measuring smaller, harder to detect shifts from stars further out. The difficulty itself left a lot of room for interpretation.
And Eddington led one of the main expeditions.
He did. And as we said, he was already a huge champion for Einstein in Britain. He went in with a strong belief.
So how good was the data he got back?
Waller highlights that the photographic plates from Principe, one of the locations, were apparently quite poor quality. There are even suggestions the math formula Eddington used to analyze them might have introduced a bias. His final calculated average displacement was just slightly below Einstein's prediction, yet it was hailed worldwide as this decisive confirmation. The narrative didn't quite match the potential fuzziness of the actual data.
So the heroic story we hear clear proof from the eclipse isn't the full picture.
Not according to Waller. He quotes the astronomer Dennis Sciama, calling eclipse observations notoriously hard to assess. Different astronomers could apparently look at the same data and get different results.
Wow.
Waller argues that based purely on the raw data from 1919, you could have maybe made a case for either Newtonian physics or Einstein's theory. He contends Eddington performed, and this is a great phrase, extensive cosmetic surgery on the results.
Cosmetic surgery.
Yeah, tweaking them until they lined up better with Einstein's prediction, maybe discarding data points that didn't fit.
Is there evidence for that?
There's a very telling quote Waller uses from the physicist Ludwig Silberstein at the time. He basically said, look, if we didn't already have the bias of Einstein's theory, we wouldn't say these figures strongly support it.
So the prior belief shaped the interpretation.
Waller strongly suspects that if the expected outcome had been different, Eddington might have been much quicker to dismiss his own somewhat blurry photos and maybe accept different results from the other observation team in Sobral. It really drives home Waller's point about how our expectations can color how we see scientific evidence.
This really reinforces Waller's broader argument about the importance of context, doesn't it? Science doesn't happen in a vacuum.
Yeah.
Social factors, politics, even just chance, they can all play a big part.
Absolutely. And he uses Frederick Winslow Taylor's scientific management and the famous Hawthorne studies as prime examples of this.
Okay, let's tackle Taylor first. Scientific management. Waller contrasts Taylor's very well-known story about scientifically picking and training pig iron loaders with the actual report written by the people involved, Gillespie and Wool. What were the differences there?
Oh, the differences are pretty stark. Taylor's famous account in his book describes this really meticulous scientific process. Selecting workers, finding the specific guy he called Schmidt based on physique and attitude.
Right, the high-priced man.
Exactly. And Taylor claimed he dramatically boosted how much pig iron they could load through this careful scientific training.
But the official report?
The report by Gillespie and Wool, who were actually there putting the system in place, tells a very different story. Waller highlights that their report says their job was simply to introduce performance-related pay piecework among an existing group of Hungarian laborers.
So no scientific selection process.
No mention of it in their report, not at the start, not later. It just wasn't there.
So that famous conversation with Schmidt, where Taylor supposedly persuades him to work like an ox because he's a high-priced man, that didn't happen like Taylor said.
Waller, building on analysis by others like Reg and Peroni, argues that iconic exchange seems to be a complete fabrication, invented by Taylor to illustrate his methods.
Wow. What did happen then, according to the report?
The report shows Gillespie and Wool initially fired the whole existing crew. Then they later persuaded a different group, Pennsylvania Dutch and Irish guys, to try the new payment scheme, mostly because those workers needed the extra money, not because they were scientifically selected.
And the big increase in loading rates.
Seems it was much less about scientific training and far more about, well, piecework incentives. And later, actually, a shortage of workers forced them to adopt some new, fairly basic methods. It wasn't some sophisticated Taylorist system initially.
Even Taylor's claim that bad press was good advertising.
Waller calls that a concoction, too. Very little evidence of any significant newspaper coverage at the time. Waller suggests Taylor just believed so strongly in his own ideas that he felt, a bit of gilding the lily was justified to sell them.
Okay, let's move to the Hawthorne studies. Foundational stuff in social science, right?
Absolutely huge. Taught everywhere.
But Waller gives him a pretty critical look. He questions the researchers' interpretations, points out biases, methodological flaws. What were the original findings that made Hawthorne so famous?
The Hawthorne studies, done at the Western Electric plant near Chicago, started off looking at physical stuff like, does better lighting make workers more productive?
Okay, seems straightforward.
But the really surprising finding, the one that launched 1,000 textbooks, was that productivity seemed to go up almost regardless of the changes. Better light, worse light, productivity improved. So the researchers, Roethlisberger and Dixon, concluded it wasn't the physical environment, but social and psychological factors. Feeling observed, being part of a special group, better relations with supervisors. That was the birth of the Hawthorne effect.
The idea that just being studied changes behavior.
Exactly. And it shifted management theory towards focusing on human relations. Hugely influential.
But Waller says, hold on, not so fast.
He does. He points out a lot of methodological issues and alternative explanations that the original researchers seem to either ignore or actively dismiss.
Like what kind of issues?
Well, for instance, in the most famous part, the first relay assembly group experiment, 2 workers were actually kicked out of the group for poor performance. Replaced.
Oh, that's a pretty major intervention.
You'd think that likely scared the remaining workers into working harder, right? Fear of being fired. But the researchers chalked up the productivity gains mainly to friendly management and group cohesion.
Convenient.
Waller also notes that one worker doing a non-standard task showed the least improvement, suggesting maybe task simplification played a bigger role than social factors. But that evidence was just dismissed as inconclusive.
It really sounds like they had a conclusion in mind already.
Waller makes a very strong case that they did. He shows how they consistently downplayed or ignored findings that didn't fit their preferred narrative about friendly management being key.
Were they comparing groups fairly?
Apparently not always. Waller mentions comparisons between groups with totally different payment incentives or study lengths, essentially setting things up to favor their conclusions.
Why? What was driving that?
Waller links it back to their Harvard mentor, Elton Mayo. Mayo strongly believed in, well, the rationality of capitalism and thought managers needed to foster worker satisfaction, partly to head off the threat of, Bolshevism, which was a big field then.
Ah, so there was a political or social agenda intertwined with the research.
In this view, yes. The Hawthorne studies were partly driven by a desire to find this third way, integrating workers happily into the existing capitalist system through better human relations. Context again.
Fascinating. Okay, another major theme Waller explores is naked ambition in science. How personal drive, maybe even ego, shapes scientific history.
Yeah, this is where some of the stories get really juicy or maybe troubling.
He uses Joseph Lister and Charles Best as key examples. Let's start with Lister antiseptic surgery. Waller argues Lister skillfully, maybe retroactively, lined his work up with Pasteur's germ theory and kind of downplayed contributions from others. How did Lister build his heroic image?
Well, Lister definitely made huge contributions to safer surgery, no question. But Waller argues he strategically positioned his work later on to align perfectly with Pasteur's germ theory, even though his initial understanding of infection was actually quite different.
How so? What did he think initially?
Early on, Lister apparently thought infection was caused by germs acting on already dead tissue in a wound, releasing harmful chemicals, not quite the idea of germs actively invading living tissue.
Okay, a subtle but important difference.
Right. And Waller shows how Lister would look back at what his rivals, like the surgeon George Callender, were doing before him, and reinterpret their methods as basically being early versions of his antiseptic approach, even though they predated his big push for carbolic acid.
So claiming their work fit his theory after the fact.
Sort of absorbing it into his narrative. Then, as germ theory really took off, especially with Robert Koch's work in Germany identifying specific bacteria.
Right, Koch's postulate.
Lister could then say, see, my methods were the practical application of these new theories all along. And his reputation just soared. Waller suggests Lister really rode the wave of these broader developments. His embrace of Pasteur around 1867 was a smart, maybe fortunate gamble that really paid off for his legacy.
A skillful navigator of the scientific currents, perhaps?
You could say that.
Okay. Then there's Charles Best and the discovery of insulin.
Yeah.
Waller presents this as a particularly stark example of rewriting history.
Yeah.
He details Best's efforts to minimize the absolutely critical contributions of Banting, Cullip, and MacLeod.
Yeah, the insulin story is famously complex and contentious. You have several key players.
Let's recap them.
Okay. Frederick Banting had the initial idea. Charles Best was his student assistant in the lab. James Cullip was the biochemist who crucially purified the insulin extract so it could actually be used safely in humans. And John MacLeod was the professor who provided the lab space, resources, and overall guidance.
A team effort, clearly.
Absolutely. But Waller argues that Best, driven by what he calls a pathological craving for intellectual recognition, spent decades systematically trying to boost his own role and diminish the others, especially Cullip and MacLeod.
How did he do that?
Waller points to numerous instances, trying to rewrite historical accounts, even putting words into the mouth of Banting after Banting had died, falsely claiming a level of partnership that the actual lab records and contemporary accounts just don't support.
Wow. That's quite something.
It is. Waller even talks about a film being made about the discovery by the National Film Board of Canada.
And Best got involved.
Oh, yes. He saw it as a huge opportunity to cement his version of the story. He tried to erase the coin toss that originally decided he would assist Banting, not another student. He invented dialogue, making it seem like he was mentoring Banting in the lab. He tried to massively downplay Kollop's essential purification work, even suggested Kollop didn't need to be mentioned in the film at all.
That's incredible. Did it work? Did the film reflect his version?
Thankfully, the film's writer, Leslie MacFarlane, was a careful researcher. He didn't just take Best's word for it, so the final film was apparently more accurate, despite Best's efforts. Waller calls Best's own reminiscences extravagantly self-indulgent and self-serving.
And there's an ironic twist at the end of this part of the story involving another researcher.
Yes, Nicolae Paulescu, a Romanian researcher.
Yeah.
Best had spent years really emphasizing the dog experiments he and Banting did in the summer of 1921 as the key breakthrough.
Okay.
But it turned out Paulescu had published very similar work, isolating a pancreatic extract that lowered blood sugar even earlier. Exactly. By constantly pushing his and Banting's arguably less conclusive early dog experiments as the main event, Best inadvertently ended up strengthening the case for Paulescu's priority claim. Waller calls it an awful irony. Best's own historical manipulations threatened to undermine the Canadian claim to the discovery he was so desperate to dominate.
It's just amazing how these personal ambitions tangle with the scientific record. Even someone like Charles Darwin, a true giant, doesn't escape Waller's critical lens entirely.
No, even Darwin gets a more nuanced look.
Waller talks about Darwin still relying on use inheritance, Lamarckian ideas, and the major challenges his theory of natural selection faced initially. It's different from the simple celebratory view.
It is. The standard story is often Darwin sweeps away all previous evolutionary ideas with natural selection. But Waller highlights that Darwin kept using the idea of use inheritance, the notion that traits acquired during life can be passed on throughout his career, even in later editions of On the Origin of Species.
Why did he do that?
He seemed to use it to explain things that natural selection alone didn't seem to fully cover, like developing specific skills or even perceived differences between human groups. Waller argues this wasn't just like a tactical move by Darwin, but a genuine part of his thinking, tied to his ideas about growth and reproduction being linked.
And natural selection itself wasn't immediately accepted by everyone, right? Waller mentions the eclipse of Darwinism.
That's absolutely right. We forget that sometimes. Despite its eventual triumph, Darwin's theory faced huge challenges for decades. Big names like Lord Kelvin, the physicist, argued the Earth simply wasn't old enough for slow evolution by natural selection to produce all life.
Based on physics calculations of the time.
Exactly. And even T.H. Huxley, Darwin's biggest public defender, Darwin's bulldog.
Yeah.
Even Huxley remained a bit unsure about the actual mechanisms of inheritance needed for natural selection to work. Waller emphasizes that for many scientists back then, other evolutionary theories actually seemed more plausible based on the evidence available, leading to this eclipse period where Darwinism wasn't the dominant view.
Waller also tackles the popular narrative of this fierce battle between science and religion over Darwin, right?
Yeah.
Especially that famous Huxley-Wilberforce debate, and also reactions to anesthesia in childbirth. He seems to argue against the simple warfare model.
He really does. He argues that the common image of this unified, powerful religious opposition to Darwinism, often symbolized by that Huxley-Wilberforce clash, that image is largely a myth constructed later by Darwin's supporters.
So the debate wasn't the clear knockout for Huxley that we often hear about.
Waller suggests Huxley's own accounts of his supposed witty triumph were probably embellished. The reality of the Oxford debate was likely much messier, less conclusive.
And anesthesia, the idea that the church condemned chloroform for childbirth as unbiblical.
Waller says that's another oversimplification. Yes, some individuals raise religious objections, but the idea of a widespread official church condemnation, not really supported by the evidence. In fact, many religious figures actually welcomed anesthesia as relieving suffering.
So who benefited from promoting this warfare narrative?
Waller suggests it served the agendas of certain people on both sides, those wanting to portray science as purely rational and religion as purely obstructive, and perhaps some religious figures wanting to rally their followers against perceived threats. It simplified a complex reality.
Okay, one last major figure Waller re-examines is Gregor Mendel, the father of genetics. Waller argues his work has been significantly misinterpreted over time.
Yeah, this is fascinating too, challenging another icon.
He suggests Mendel didn't really understand genes the way we do now, and his ideas were seen very differently in his own time.
Right. Waller argues our modern textbook understanding paired genes, chromosome segregation, independent assortment doesn't perfectly map onto Mendel's own thinking. Mendel focused on observable characters or traits in his pea plants. He meticulously tracked the statistics generation after generation.
Famous ratios.
The famous ratios, yes, like the 1.2.1 ratio in hybrids. But Waller argues Mendel might have seen these hybrids as a kind of special case, a compromise or blending of parental elements, contrasting them with the perfect union in pure breeding plants. It's not clear he pictured stable, paired genes sitting on chromosomes like we do.
So the laws of inheritance we attribute to him like independent assortment. He didn't formulate them quite like that.
Waller makes the point that Mendel knew nothing about chromosomes. So the law of independent assortment, which is about genes on different chromosomes inheriting independently, couldn't have been conceived by him in its modern form. His genius was in the experimental design, the careful counting, the quantitative analysis of the outward effects.
So why did he become the father of genetics?
Waller suggests it was partly later geneticists, maybe in the early 20th century, looking for a clear historical figurehead for their new field, and maybe also a way to settle priority disputes among the biologists who were rediscovering similar inheritance patterns around 1900. The story of the ignored monk whose genius was finally recognized also fits that romantic view of science we talked about earlier.
Okay, so pulling all these examples together, Pasteur, Millikan, Eddington, Taylor, Hawthorne, Lister, Best, Darwin, Mendel. What are the broader takeaways here for us, for the learner, about how science actually works?
Well, I think Waller's big message is that scientific progress is rarely, if ever, a simple, linear, purely objective march towards truth.
It's messier.
Much messier. Initial ideas are often based on limited, sometimes ambiguous evidence. The scientists themselves bring their own biases, preconceptions, ambitions.
The human element.
Absolutely. The desire for recognition, funding, proving rivals wrong, even national pride. These things can definitely influence how research is done, how results are interpreted, and how the story gets told later.
And the context matters hugely.
Enormously. The social climate, political pressures, the dominant scientific theories of the time, they all shape what questions get asked, what evidence seems convincing, what interpretations gain traction. Waller warns against presentism, judging the past purely by today's standards. What counts as good science can shift.
But does this mean science isn't reliable, if it's so influenced by human factors?
That's the interesting balance. Waller seems to suggest that while the initial discovery phase can be messy and subjective, the process of science over time, the constant testing, replication by others, peer review, critical debate within the community, that's what ultimately gives scientific knowledge its reliability and robustness. The messy parts often get weeded out eventually, even if the popular history books don't always reflect that process accurately.
So as we've seen through these, really eye-opening deep dives into these historical accounts, the path of scientific discovery isn't that straightforward march of pure objectivity we sometimes imagine.
Not at all. Human stories, with all their complexities, ambitions, biases, are just deeply woven into how scientific knowledge develops.
Hopefully this exploration has given you, the learner, some perhaps surprising insights, and maybe encouraged a more critical look at the scientific narratives we often just accept.
Yeah, hopefully it sparks some curiosity about digging beneath the surface of those heroic tales.
Waller's book really poses a crucial question for all of us, doesn't it?
Yeah.
How do we balance our need for inspiring stories, for heroes, with the vital importance of historical accuracy? Especially when trying to understand something as complex as scientific progress.
It's a real tension.
His work suggests that by carefully trying to separate fact from fiction, by understanding the context and the human factors, we actually end up enriching our understanding, not just of science, but maybe the human condition itself, and this fascinating, imperfect way we have of figuring out the world.
Well said. It makes the history of science even more interesting, I think.
Thanks for listening.
Until next episode.